So, we've covered a few machines recently that can handle some high performance materials. But which will perform the best? And if you're someone that's never experienced these filaments before, can just anybody print with them now? Yes, today we're focusing on the wild world of composites. I feel like in the past couple of years, every brand has some kind of fiber reinforced filament now, and I'm here for it. So we're talking about materials that have been reinforced with carbon fiber or glass fiber, the addition of which leads to enhanced rigidity and strength in a lot of cases. Another good benefit of the addition of these fibrous materials is warp-prone materials like ABS aren't so warp-prone anymore because they have extra structure in there providing rigidity. So today we're testing 3 different machines: Bamboo X1 Carbon, Qidi Plus 4, Creality K2. Each machine is going to take their turn printing a couple of models out of 3 different filaments. The first of which is this super cool purple ABS glass fiber. That's from Qidi Tech. The next filament is a Fibron, which is a Polymaker product, and that's the PA6 glass fiber, so a nylon. And the last one is a super no-name brand. I think I got it on Amazon, but I don't really remember. ASA carbon fiber. We're going to look at a lot of different things and try and compare as much as we can from these few tests that we're doing. But we'll look at a little bit of accuracy and quality of several different scenarios that machines often have to print under. Overhangs, bridging, top and bottom surface, those kinds of things. But more importantly, I also want to answer, is the composite stuff approachable now? So if you're like Paul and you've never printed with any of these composites, can you buy a modern machine, turn the thing on, set your preset, and just print now?
Oh, yeah!
Let's find out. Now before we get started, I didn't mention this printer initially, but we also used the P1S a little bit. We just put a bunch of pieces in this to make sure it could print abrasives, and I thought this would be a good time to stretch its legs a little bit. So we ran a couple of prints with some composites through that. It's got hardened gears, a lightened extruder, upgraded cooling fan duct. We put a light in there. You can check it all out in the video that we did a couple of weeks ago, but it's pretty sweet. Especially because, like, it can do what the X1 Carbon can do now, and it's $500 cheaper this way. You like that? Yeah, you like that. So with that in mind, it was hard to not include that machine in this video somehow. So what I did was kind of used it as the pilot of sorts. This was going to be the first one where I wanted to flesh out some ideas, figure out what tests I wanted to do, and just run through some prints generally. Now the reason why I didn't want to fully include it was because it's actually got a 0.6 nozzle in it instead of a 0.4, which means it's not going to be a one-to-one comparison like the other machines will be. So it's more reference material and less direct comparison. And it'll give us a little bit of insight between printing with a 0.6 and a 0.4 on machines that are similar, like the P1S and the X1 Carbon. So I started the printing using a PET-CF that I have from Polymaker. It's a super good filament and I like it for a lot of different applications, but it's not great for everything. So I figured it'd be a good candidate and I would print 3 prints instead of 2. I wanted to do the torture test, a larger torture test, and then the standard nacho print. Well, I ran out of filament because doing those prints and then a couple more on the Qidi meant that the volume of filament we've used exceeded 500 grams. And apparently this roll was only a 500 gram roll. Who didn't look at that when they bought it? Me. So yeah, by the time I went to test it on the second machine, which was the Qidi, it ran out. That wasn't gonna work. That was when I landed on the testing method we're gonna be covering, which is one of those torture tests and one standard size nacho. So a few notes on the approachability for this one. For starters, the PET-CF absolutely held on to that textured PEI gold build plate that Bamboo has. As is the case with most of these high-performance materials and composites, it's usually better to use a smooth build plate or a high-temp engineering build plate instead of these standard textured ones. Some of these filaments just bond to that texture too well, and in some cases you'll even rip up the PEI powder coating instead of ripping the model off of the plate. But more on that later. Back to these prints, the first one's released with a little bit of persuasion and a lot of damage to the model. So that was when I made the switch to these super cool build plates that I love printing with. This is one of the CryoGrip build plates from BQ or BigTree Tech. It made the testing go a lot smoother, and if you're trying to print with some of these materials, this is an excellent option. But beyond that, setup was pretty simple. I selected the filament preset in Orca Slicer for Bamboo's PETCF, and that got everything pretty close to the point where I could print a model successfully. After I had some layer adhesion issues on the first print, I decided to bump the temperature up like 10 degrees or so, and print the second one, and had much better results. So another thing to note about these composites before we really roll into the testing is that they like to wick up moisture. With that in mind, I opted to print each of these spools directly from a poly dryer dry box, and in most cases I ran the dryer before or during the prints. This was just an effort to eliminate any other variables that there could be, because I haven't messed with a lot of these materials and I didn't want there to be any unknowns. But again, beyond that, there weren't really any issues. There's a little bit of trial and error, and if I was somebody that hadn't used these materials, after figuring out those steps, this wouldn't be a problem. The standard presets did most of the heavy lifting, and they got me fairly close to something suitable, and all I had to do was print a couple of times and tune it just a tiny bit. There was a time where we filmed all of our videos like this. All right. Let's judge some of the quality of some of these prints here. So first off, we've got the PETCF that we printed on the P1S that had the 0.6 nozzle on it. First thing we're going to look at is the overhang performance. It looks pretty good considering how steep that overhang is. It's not sagging all that much. I think this is a 0.42 layer height, whereas everything else is a 0.28. So pretty significant jump there. Yeah, so looking at the small one, it looks about the same. Another interesting thing about the 0.6 nozzle is it can't resolve any of the text on the top face really well, so that's why it all just looks like squiggles. All right, bridging, how did we do? So the bridging on the standard size is excellent. You can't even tell that it struggled at all. The giant one did excellent. The bottom surface on both of these, fairly consistent. On the bigger one, you can kind of see where it was a little bit inconsistent in that corner. Top surface, we kind of mentioned, it looks smooth and consistent, but being such a big nozzle, it can't quite resolve as well. The letters on the side look pretty clean, and then the layer stacking. These little guys here are a good indication of how well the layers are stacked. And it looks pretty good. So these machines can print some tough stuff, but what if you need to print tougher stuff? This episode's sponsored by PCB Way, and if you need to print something super specific, they've got you covered. Want to print a titanium nacho for no good reason? Same here, and PCB Way can totally do it. SLS, FDM, SLM, SLA. These are all letters that mean different things. And PCB Way, they know what those letters mean, because those are all 3D printing processes that they offer in-house. Not to mention the PCB, CNC, and general fabrication services they offer. If that sounds like something you're interested in, check the link in the description and support the people supporting this channel. Thanks PCB Way for sponsoring this video. Now on to the Qidi Plus 4. This machine surprised the heck out of us a few weeks back when we reviewed it. It comes with standard hardened internals, ready to print super hot and abrasive straight out of the box. It's got a chamber heater that aids in heating up the enclosure, allowing you to print really warp-prone materials with no problem, and the bed goes up to 120 degrees. Like I mentioned, I was starting off by printing PETCF, that's Fibron, which is a brand that Polymaker has. And if there's anything else that you see during this video that you want to learn more about, I've got links below that helps out the channel as well. If you buy something from one of our links, we appreciate that because it allows us to continue making these videos on top of our day jobs and family events and all the things that we have going on. So like I mentioned, the PETCF ran out during the nacho print. And unfortunately, the print didn't stop either. The machine thought it still had filament in it. So I figured the runout sensor just didn't work, and that kind of bummed me out because I really like the Qidi, but if the filament sensor wasn't working, then I'd have to let you guys know, and then I'd be pretty bummed about all the people that I recommended get this machine. Well, luckily, I went to go load up the next filament that we were actually going to use for the testing, which was some ASA carbon fiber, and the real issue presented itself. When I was trying to load the filament, it would not let me load it. No matter what I did, I could not get it in past the filament runout sensor. After taking the tool head cover deal off, you know what I found? A little ball of tape was wedged in there. That's why the print didn't stop. That's why the runout sensor thought there was still filament in the machine. The stupid ball of tape at the end of the filament got stuck in the machine. But with that removed, we could press on with what began to be our standard tests. I loaded up the carbon fiber ASA and pushed play. Now, remember when I said you should use the smooth plate for these materials? Remember that?
Oh, yeah!
That was an instruction that I did not follow. And unfortunately, what happened as a result of that decision was this carbon fiber ASA absolutely welded to the standard textured plate that comes with the Qidi. In fact, it welded so bad that I still haven't tried recovering it, and instead I just took the same blue cool plate that I use on my bamboo machines and just stuck it in place of where the standard bed goes. Now, some machines are going to know if you don't have the right plate on the right machine. Like the bamboo would have yelled at me all day about that. Some machines probe the bed before every print, and they're going to see that there's no metal there. I can't get a good probe. Luckily, the Qidi only probes the area being printed in before every print. And the prints fit just fine on this plate, so it had no idea what plate was on there. It didn't have any problem using that plate. Didn't matter if it was from a bamboo or an A1 Mini or whatever. And from there, the printing was only made simpler. The ABS-GF did just fine. The PA6GF did just fine. I got through my other ASA print, no worries. As for how approachable the filaments were on this machine here, I've got some thoughts. The experience honestly was largely similar to the P1S. As long as I wasn't using the standard build plate, which was something that we figured out from the P1S testing, everything went pretty smooth. The standard presets did all of the heavy lifting once again, that is if there are presets actually available, but by and large what was available got me pretty close. So there wasn't an ASA CF preset on its own, but I used the standard ASA one. When using ASA, the chamber needs to be heated to help prevent warping, and the Qidi did a super good job of taking that into account in its preparation for the print. It heats up the tool head, makes sure the filament extrudes, and then cools down the tool head to prevent any oozing because it knows that tool head's going to be parked for quite a while. And it was. It took like 10 or 15 minutes before the whole chamber was properly heat soaked and the machine could resume printing. And because of that, all the layers laid down really well, everything was super consistent, I didn't have any warping issues either. And I think that's largely because the machine does really well preparing based on that preset. And the same went for the other filaments. I used presets that were as close as I could get, and in the cases that I didn't have a preset available, I got one kind of similar and referred to the manufacturer's website or Google to get temperatures and everything dialed in. From there, I didn't have to do anything special. There were no tuning towers, there was nothing exceptional that took up a lot of time to even get a usable model, and that further reinforced how impressed I am with this machine and its stock profiles. Now, if only those Qidi smooth plates would come back in stock. Alright, this would surely be the real test. This is what the whole video is about. For the K2, we were going to have Paul run these prints, because he's the one that owns the machine. Even though it's Corey's, it's parked at Paul's house. And he's never used any of these filaments before. Ever. This was going to be the ultimate way to test how user-friendly this current generation of printers is to printing composites. Though it sounds like there were some struggles, we got some usable results, and overall it went pretty well. Mostly.
Okay, trying out some composites. Number one situation, figuring out this machine, making it go into this machine, and not go into this machine. Totally can do that. Not an issue. I think something has to happen here.
So starting off with the ASA carbon fiber, Paul had the same issue that I did. The stuff stuck so very well to the stock textured build plate that it was an absolute chore to get off of there. Luckily, it released reasonably well with quite a bit of effort.
Let's stand. Man, Yep, there we go.
Next was the ABS glass fiber, and that had to be by far the easiest one to print with, at least on this machine. Of course, he ran into issues finding presets, but once he cobbled that together and started the print, we were off. The filament printed super well, and this color is sick. You like that? Again, this one stuck to the build plate pretty hard, but with some preemptive glue sticking, came off okay. I mean, he didn't even need to flex the plate. He was able to just muscle it off.
That good old glue. There we go.
Finally, the nylon. The PA6 glass fiber that we were using was by far the most technical material that we had of the three. It required the highest nozzle temperature, stuck to the bed the hardest without a doubt, and that's kind of evident by the rapid, unscheduled deconstruction that occurred when Paul tried to take it off the bed.
He's off the plate, but that's how much he sticks to the bottom. I'm gonna have to work that out. If I don't know where to go, or who to turn to.
All right, the K2. Although there were some issues, I'd say it's right in line with what we should expect from this generation of machines. It's smart enough to help bridge any gaps that you may have in your filament knowledge. There's a decent variety of presets that are available right on the machine, which makes things go pretty smooth. That said, the presets on the machine and the presets in the slicer, they don't always talk to each other. But similar to the other machines that we've messed with, a little bit of adjustment and we're getting successful models. The K2 didn't skip a beat. It's got the hardware to support the abrasives, it's got software that can drive it all, and the user experience is intuitive enough that somebody with zero experience with these materials was able to pull off some clean models. And it didn't take him all that long. Go ahead and leave Paul a comment below saying good job, because this is his first time using any of these materials. He's more of a PLA, PETG guy, and he knocked this stuff out just in a couple of days. First time and everything. Moving on finally to the X1 Carbon. I figured this one would go the smoothest because we figured out all the other quirks with the other machines using these materials, so what could this one throw at us that we didn't already know? Of course, I stuck with the sick blue build plate. I used standard Orca slicer profiles wherever I could, but when I went to print the ASA carbon fiber nacho, for some reason it failed. Like, the print came free from the build plate and it ended up just sliding around when the print was pretty close to being done. Luckily, the spaghetti detection feature came in handy here. It saw that something was wrong, it notified me, and I aborted the print. So I gave it another shot, but this time I used a brim around the model to see if that would help aid in sticking the thing to the bed. It failed again. The torture tester went just fine, but for some reason the nacho tester could not happen. So I just took the loss on it and decided we were done with the ASA carbon fiber. It's time to move on to the next print. So I moved right along to my purple glass fiber ABS and the PA6 nylon glass fiber that we were using. Everything went off with no problem. Didn't have any more failed prints, no more spaghetti detection necessary, no problems. Especially the nylon, which I was expecting a little bit more of a fuss from, but it did better than the ASA did on this machine as well. I don't know what the deal is. Now, in terms of approachability, the X1 Carbon is a little bit of a mixed bag, which is not what I thought I was going to be reporting. Bamboo's supposed to be the most user-friendly of them all, and I think it could be argued that that's still the case. But there's a lot of filament presets that it does not have available. For the ASA carbon fiber and the PA6 glass fiber, I had to make presets and input the temperatures manually. That's not to say I couldn't have used other presets that were kind of close, but I was worried that they weren't quite gonna jive. And this isn't a big deal, we had to do this on all the other machines, but for a super beginner, the Bamboo was no better than the K2 or than the Qidi. Everybody talks about how approachable and user-friendly Bamboo is. In this case, it's just the same. Everybody's caught up. And as a Bamboo fanboy, I feel that it's important to point this weakness out. Sure, they have far more presets available than any other printer I've seen, but this is still a weakness, and it's still an area that we need some growth. Not only from Bamboo, but from everybody. Otherwise, similar to all the other ones, once you know about the build plate limitations and you know how to get your filament set up just right, this machine's just going to print its little heart out. Unless you're using carbon fiber ASA. For some reason, it just couldn't print the Nacho. Still don't get that. We're just going to do some direct comparisons now. X1 Carbon, Qidi, K2. Well, the K2 looks pretty good, but I think its layer height was different. The K2's looks really good. Top surface looks a lot better than the Carbon, but it looks better than the Qidi as well. I think bridging's best on the Qidi. Looks like the K2 struggled the most with the bridging. Layer stacking, K2 and Qidi are pretty well neck and neck. I think the Carbon takes it just by a little bit. Overhangs though, everybody kind of looks the same. Bottom surfaces, it looks filled in super well and consistently. But between Qidi and Bamboo, Qidi has some rippling going on, so I'd say the Bamboo takes it for bottom surface, even though it didn't stick to the plate very well. What else we got? Letters on the side? Sure. The Bamboo's looks terrible because it didn't stick to the plate. Otherwise, the K2 definitely has it over the Qidi, but again, K2 is at a different layer height. The Qidi seemed to do better bridging over the embossed letters though. Okay, back to you. So after all that's been said and done, what did we learn? How did we do? Well, in short, printing with composites is much less daunting than it used to be. Sure, the standard presets leave a lot to be desired, and you're not always going to find something perfectly dialed in for your exact filament. But 2 years ago, we didn't really have standard presets. Most manufacturers were just shipping out filament, shipping out printers, and it was up to you, the user, to tune that stuff in. So progress has certainly been made. It's a lot more standard for manufacturers to ship presets, whether they're good or not. It usually gets you closer at least. It's better than having nothing, in fact. And that's a step in the right direction. But beyond that, overall, I would say we are super spoiled for choice. These are 3 great machines. They're available at different price points depending on what you want to accomplish and what features you want to have. Combine that with perfectly usable presets that are easily adjusted to tune them in. Well, I feel confident saying anybody that can already 3D print should have no problem figuring out how to print with these composites if they want some more high performance parts made with high performance materials. Bye.